Welcome, data professionals. Today we are diving into Snowflake Cortex's Classify Text function, a powerful tool for bringing natural language categorization directly into your SQL pipelines. Let's get started. Let's start by defining Classify Text. In the era of unstructured data, making sense of free-form text like emails, reviews, or logs is critical. Classify Text is a purpose-built Snowflake Cortex AI function that reads an input string and assigns it to a specific category from a list you provide. Why is this a game changer? Historically, categorizing text required data scientists to train, deploy, and maintain custom NLP models. Now, any data engineer or analyst can perform highly accurate, zero-shot text classification directly using a simple SQL function. It returns a structured JSON object containing the predicted label, making it incredibly easy to parse and use in downstream analytics. Keep in mind, Snowflake recently introduced AI Classify for multi-label tasks, but Classify Text remains a fully supported, highly efficient tool for your single-label categorization needs. Looking at this flowchart, the architecture is brilliantly simple. On the left, we feed two inputs into the Classify Text engine: the raw input text we want to analyze, and an array of target categories. The Cortex AI model processes the semantics of the text against your categories and outputs a clean JSON object containing the winning label. There is no infrastructure to manage or external API calls to make. The data never leaves Snowflake. Now, let's look at how to actually write the code. The function syntax is straightforward: classify text, followed by your input text, your list of categories, and an optional settings argument. The first argument, the input, is a string. Note that it is case-sensitive, meaning different capitalization might slightly alter the model's interpretation. The second argument is your list of categories, provided as an array. You must provide at least 2 categories, and you can provide up to 100 unique labels. These labels are also case-sensitive. The function evaluates the text and returns a variant data type, specifically a JSON object. You simply extract the label key from this object to get the assigned category. This standardized output allows you to easily cast the result into a standard varchar column in your tables. Let's walk through a practical syntax example. Our input string is "I love this pan." We pass an array of 2 categories, travel and cooking. The function evaluates the semantic meaning of the word pan, recognizes it belongs to the culinary domain, and outputs a JSON object with the label cooking. You can embed this exact logic in a select statement to categorize millions of rows in seconds. Here is where we move from basic usage to expert-level prompt engineering. Sometimes, a single word isn't enough for the AI to understand your business logic. If your categories are ambiguous, you can pass JSON objects instead of simple strings. Inside these objects, the label field is required. But crucially, you can add a description field. This allows you to write 1 to 2 sentences explaining exactly what this category means, guiding the LLM's decision-making process. For even higher accuracy, you can include an examples field. This takes an array of up to 20 text snippets that perfectly represent the category. This technique is known as few-shot prompting, and it drastically improves classification accuracy for highly nuanced, domain-specific text. This class diagram illustrates the schema of a category object. Instead of just passing finance, you pass a structured object. The label is finance. The description explains it covers money, stocks, or banking. You could also attach an array of examples like, "The stock market rallied today." By structuring your categories this way, you provide the Cortex LLM with a rich, contextual map, ensuring it makes the right choice even when the input text is highly complex. Continuing our deep dive, let's explore the third argument of the function, the options object. Even with detailed category descriptions, the model might need to understand the overarching goal of what you are trying to achieve. You do this by passing a JSON object containing the task description key. The task description is a short prompt, ideally no more than 50 words or 3 to 4 sentences, that explains the context of the job. For example, you are an IT routing assistant. Classify the following employee request into the correct IT support queue. When you provide this high-level directive, the model adopts the correct persona and context. This is especially impactful when the input text contains overlapping themes or ambiguous language that could technically fit into multiple categories. This diagram shows the complete, optimized data flow. We have our input text and our categories feeding into the function. But notice the dotted line from the options box. The task description wraps the entire operation in a layer of global context. It acts as a lens through which the LLM views the text and the categories, ensuring the final output aligns perfectly with your specific business intentions. As senior data professionals, we must architect for both accuracy and cost efficiency. First, security. To execute this function, your role must be granted the Snowflake.Cortex user database role. Now, regarding billing, Cortex AI functions are billed based on token consumption. It is critical to understand that the input text, the category labels, your custom descriptions, and your examples all count as input tokens. Furthermore, because classify text is a scalar function operating row by row, your category descriptions and examples are processed and billed for every single record in your query. If you classify 1,000,000 rows with a massive set of examples, your token count will multiply rapidly. The best practice is to keep your descriptions concise, 1 to 2 sentences, and only use examples if the model struggles with zero-shot classification. Look at this token aggregation diagram. Your total billable tokens are a sum of the input text, the category labels, and your descriptions and examples. Notice the critical detail on the third path. The metadata tokens are multiplied by your row count. This visual serves as a reminder to balance the richness of your prompts with the scale of your dataset to maintain optimized compute costs. To guarantee production-grade results, you must follow these prompt engineering best practices. First, use plain English. LLMs are trained on natural language, so avoid using internal company jargon, special characters, or obscure codes like Cat1A for your labels. Name the category hardware failure instead. Second, ensure your categories are mutually exclusive. If you have a category for billing and another for invoices, the model will get confused because they mean the same thing. Combine them or clearly differentiate them in the descriptions. Third, try to limit raw code snippets or heavy system logs in the input text. While the function won't fail, excessive non-language characters degrade semantic understanding. Finally, when writing category descriptions, highlight the unique differentiators. Tell the model exactly what separates this category from the rest. This mind map summarizes our best practices into 3 pillars. Natural language emphasizes plain English and zero jargon. Category design reminds us to keep classes mutually exclusive with clear differentiators. Input cleanliness focuses on passing actual text rather than raw machine logs. Adhering to this map ensures your classification pipelines run with maximum accuracy and reliability. Let's apply this to a highly impactful, real-world use case: support ticket routing. Imagine your company receives thousands of customer emails daily. Currently, human agents waste hours just reading and forwarding emails to the right department. We can automate this entirely. We set up a Snowflake pipeline that reads the incoming tickets table. We pass the email body into classify text and provide an array of categories: billing, technical support, returns, and general inquiry. We add a task description explaining that the goal is to route support emails. The function runs in seconds, tagging every email with a precise JSON label. We then use a Snowflake task to parse that JSON and automatically route the ticket to the correct department's queue. This reduces response times from hours to minutes and saves massive operational costs. This sequence diagram shows the automated workflow in action. The system ingests a raw customer email into Snowflake. Snowflake seamlessly calls the Cortex AI classify text function, passing the email and the target departments. Cortex AI evaluates the text and returns a JSON object identifying it as a billing issue. Snowflake parses this label and immediately auto-routes the ticket to the finance department. It is a completely touchless, intelligent pipeline. Let's summarize what we've learned. Classify text empowers you to perform advanced, natural language categorization directly within your SQL queries. Whether you use simple string arrays or highly detailed JSON objects with examples, it offers the flexibility needed for enterprise accuracy. By leveraging task descriptions and adhering to plain English best practices, you can automate tedious manual workflows like ticket routing and sentiment tagging. Most importantly, it does all of this within Snowflake's secure boundary, ensuring your data never leaves your control. It is time to start building smarter, AI-driven data pipelines. Thank you for joining me in this deep dive. I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram serves as your implementation checklist. Start by identifying a manual tagging task in your business. Define your categories in plain English. If the task is nuanced, add descriptions and examples. Finally, run the classify text function over your data table. Follow these steps, and you will have successfully achieved a fully automated, scalable AI pipeline. Thanks for watching, and see you at quicktechie.com.